Hello, everybody, and welcome back to another weather briefing. Today, we are going to discuss two different weather events, and the first one we are going to talk about is the severe weather event for tomorrow, February the 12th, 2025. The SPC has outlined a slight risk, a level 2 out of 5 for severe weather, and the threats are going to include all hazards. So we're going to see tornadoes, and right now they have it a 5% tornado threat, and this is going to include portions of New Orleans, Louisiana, Mobile, Alabama, Columbus, Birmingham, Alabama, Jackson, Mississippi, and then close to the Alexandria area in Louisiana. 2% surrounding around that, but pretty large area for a 5% tornado threat. And going to wind, it's going to be 15% in much of the same areas as that 5%. And there is no hail threat. And we will get into the details on why we are expecting these hazards tomorrow. It is a pretty robust looking setup, and it might be upgraded in the future as we get into closer outlooks. But let's jump into some current conditions right now. Currently on screen, we have the mosaic radar across the Gulf Coast states, and we can just see a large plume of showers ongoing across the Gulf Coast. And these are going to continue off to the northeast, not really posing any severe threat, really just some thunderstorm activity. We're going to need to focus, though, on this stuff back out to the west here in Texas. This is expected to reinvigorate itself as it moves off to the east into a pretty favorable environment. Texas looking like the first to get hit by this sequence of severe weather. And just jumping back to the day one outlook, there actually is a severe weather risk outlined across portions of southeast Texas, level 1 out of 5, just for this nighttime period. And the main hazards are going to include just wind and maybe some localized hail, but this is going to be for the overnight hours through 6 a.m. On Wednesday. Again, one out of 5 severe weather risks, so not anything too robust, but that's going to be the precursor to a more substantial setup across the Gulf Coast states here, including Louisiana, Mississippi, and Alabama. Going into some observed upper air data now, we're going to look at the upper air jet stream. And something that is of note is obviously this big trough centered across the western side of the U.S., the axis striking through the western side of the Rockies, and just a very large expansive jet stream across the entire United States right now. But the key feature here is this belt of more enhanced flow relegated to the southeastern side of the U.S. This is our subtropical jet stream that is making its northward advance, and that is favorable for northward transport of tropical air and moist air into the central United States. And so, with that in tangent with a couple other features, we are starting to get quite a bit of moisture at the surface right now. And if we look at our dew points, they are still shunted off to the south along the coast, but with surface low development expected across northern Mexico, we're going to get strengthening of those southerly winds and most of those higher quality dew points to get inland across Texas, Louisiana, Mississippi, and Alabama. But going back up to now 700 millibars, we're going to zoom into the southwest and just kind of look at why we're getting some of these storms to be ongoing right now in the southeast, and also some of the precursors to storm initiation going into tomorrow, because there's looking to be two different rounds. As you can see in the southwest at 700 millibars, we have a very wavy pattern, and you can see that with these black contours, just these wavy patterns, and we call these little waves short waves. And where they dip down or dip to the south is what we call shortwave troughs. And we have a few shortwave troughs embedded within the flow here, maybe one right in here, one back in here, and one back in through here. But this shortwave that we're seeing just ahead across central Texas is really what's getting most of these showers ongoing to the east of that axis. But most of these showers that are expected to explode over the next couple hours and possibly some severe thunderstorms is going to be due to this shortwave back in here across West Texas. Just ahead of that axis is where we would expect the warm air advection and strongest forcing for ascent to be manifesting. And that's going to be our first round of severe weather that's going to take place. And that shortwave will continue off to the east and go through Louisiana, Mississippi, and Alabama, inducing some severe weather and likely to a greater extent than within Texas overnight tonight. And then back to the west, one more shortwave, and that's going to be our main shortwave. It's going to get storms going on a more broad scale and a lot more robust as well. So we're going to pack more of a punch in terms of storm coverage. And so we're going to have to pay attention to these three little shortwaves and see how they evolve over time and their timing and their translation through the southern plains and to dictate when we're going to get storms and where. Again, we saw already down at the surface, we have a very large plume of surface moisture right off the coast and barely making its way inland. We also have a surface cyclone or a surface low pressure system off to the southwest. Right now, very broad cyclonic flow in the southwest, but this area of low pressure here in northern Mexico is going to be the focus here, the cyclone of interest, and this system is going to move off to the northeast over the next couple hours and deepen with the approach of that upper level trough and that approaching jet stream. And then off to the east, we can see as well there is a pressure tongue and associated wind shift associated with a surface frontal boundary. You can call this whatever you would like, but it's quite stationary right now. So some sort of boundary lingering across the southern plains, but this is going to be reinforcing where the cyclone tracks through tomorrow. And so wherever this positions is going to dictate where this cyclone in northern Mexico tracks. And right now it's looking to track just along this frontal boundary through this zone in here, and so we're going to have to look where this, how this evolves over time, because usually just ahead and southeast of that track is where the most robust severe weather is conceptually favored. Now looking at some raw surface data just to look at the actual thermodynamic characteristics on each side of this surface frontal boundary that we just annotated. Let's sketch that in once again on either side of that wind shift, and we can see that temperatures to the south are very much in the mid 60s and low 70s, whereas to the north they are in the upper 40s, mid 40s, and even into the 30s. So definitely a thermal gradient. And then in terms of moisture, we've got 60s dew points and even some in the upper 60s and low 70s dew points right off the coast. So definitely a moisture gradient as well. And then one last thing across the boundaries that we're seeing here is a wind shift. So southerly winds to the south and more northeasterly winds on the other side. So definitely a clear boundary and some sort of source of convergence to focus convective initiation tomorrow afternoon and morning. So again, gonna have to see how this evolves. Now we can look at some observed soundings across the region. Here in Brownsville and deep southern Texas, we're going to look upstream on the surface to see how the low-level thermodynamic environment is going to look as it gets advected northward. So looking in South Texas, we can see near the surface a very buoyant, moist atmosphere, 78 over 69. And so it's very buoyant, very moist, and a layer of very steep lapse rates in the mid-levels as well. 8 degrees Celsius per kilometer lapse rates is setting in, and so if this air mass gets advected north and east, we're going to have a pretty favorable environment across Louisiana, uh, Mississippi, and Alabama. And so definitely a good look upstream. And then if we look actually in the target area right now, this is in Lake Charles, very moist, a lot of convective overturning going on right now, so not very representative. Over in Louisiana, very much the same thing, but we do see a bit of an indication of that surface moist layer making its way inland. And if we look up in Shreveport, that's north of the front, and so we can again see the difference here, 45 over 45 at the surface, so a much different thermodynamic profile at the surface and a stout low-level inversion. So overall, got a pretty good look at the observed conditions and what we're really expecting on a synoptic scale. And so let's look at how it's going to evolve. We're going to look at the overall pattern using the medium range model called the NAM. And again, starting off at 500 millibars here, we have this expansive long wave trough off to the west that's going to continue to dig to the southeast, and much of its flow is going to continue to overspread much of the southern plains. But notice here at around 9 and 12Z on Wednesday here, we have this subtle perturbation in the flow that's starting to eject through portions of northeast Texas, southwest Arkansas, and northwest Louisiana. This is going to be our first initial shortwave that we annotated, ejecting through the southern plains and getting that first initial round going overnight tonight and into tomorrow morning. Uh, it still could pack a punch, and so we have to monitor the thermodynamic characteristics around this shortwave to see if we're going to have a lot of robust severe weather. Zooming in to get a better look at that perturbation, here that is across northeast Texas, you can see the curvature in the height contours and also an associated enhancement in the flow just on the base of that. And so a clear shortwave and an initiation mechanism for storms in the open warm sector come early morning on Wednesday. It's going to drift off to the northeast very rapidly and initiate storms across much of the region into Louisiana, Mississippi, Alabama throughout time. And then again, we have the main wave that fully ejects through the region throughout the nighttime hours, the entire jet streak fully elongating through the open warm sector. And by the time we get to the around midnight time period, we're sitting basically on the right entrance region, which is pretty favorable for divergence. A pretty good look in terms of forcing for ascent on a large scale as we get into the overnight hours. So definitely uh, more storms and more robust storms getting into the later portion of the period. Going off to the east at the same time, still midnight, and we can see the reflection of that shortwave across the Gulf Coast states in Alabama, Mississippi here. See the subtle perturbation in the flow, and so again a reflection of some convective signal going on here, and so definitely an area of interest. Jumping down to 700 millibars and going back to the western sector here, seeing how that initial shortwave evolves. Again, we see this initial shortwave going through portions of Louisiana and moving off to the east with that initial complex that's ongoing right now. And then this one back to the west across Texas is going to initiate more storms just ahead of that throughout the overnight and morning hours. And so definitely a focus for convective initiation over the next couple hours as we get that northward advancement of that warm sector. And you can see the enhancement in the flow here, very strong flow and upwards of 70 knots at the base of that perturbation by 12Z on Wednesday. Continues to eject off to the east and enhance quite a bit, up to almost 80 to 85 knots. So quite a strong shortwave trough. But again, back to the west, we see another enhancement of a secondary shortwave, and the main shortwave, again, going to force more storms to erupt across the open warm sector, possibly more robust and more severe. And so going into the overnight hours, conceptually going to favor more robust, stronger, more severe storms. Now we're going down to 850 millibars where we can diagnose that low level shear a little better, and we look at what is called the low level jet. And going into the morning and afternoon hours, we see a very strong 50 to 60 knot low level jet elongated across Mississippi, Louisiana, and Alabama. And it's going to continue to expand and strengthen throughout the overnight hours here. And by 6Z midnight, we've got 60, 70 knots across Mississippi, or excuse me, Alabama. So Alabama is looking like the really central portion of the event here, and if there was to be an upgrade, it would look to possibly be across that region. We've got just very strong dynamical forcing and kinematics to support strong low-level shear in a moisture-laden environment. So speaking of moisture, let's look and see how those dew points evolve going into the morning. Again, we're expecting that surface low off to the west to deepen, so that would strengthen the southerly winds ahead of it. And that would yield northward advancement of that high quality moisture. And so going to the afternoon hours of Wednesday, seeing robust mid to upper 60s dew points and even some low 70s there across to southern Mississippi and to eastern Louisiana. And then going into the overnight hours, seeing much of that moisture maintaining itself, especially across that Alabama region. Very large warm sector and very expansive in a west to east component. So seeing A lot of real estate for storms to work with from west to east here. You're going to have to pay attention from Louisiana all the way to Georgia, and then as far north as possibly um, southern Tennessee. We'll have to see if the moisture really does get that far north. It doesn't really look like it on this model output, but definitely something to keep in mind. So now what we're going to do is we're going to look at a set of soundings or thermodynamic diagrams across the open warm sector here. And let's start in the morning hours here across southeast Texas, just to get an idea of this environment down here. And instability wise, we have about 800 mixed layer cape and about 1200 most unstable cape, so not terribly robust, but is suitable for some strong storms, especially if we consider the deep layer shear in excess of 54 knots. The effective storm load felicity just about 225 meters squared per second squared. So a pretty sheared environment overall, but thermodynamically speaking, it's not super unstable. Let's go into the early afternoon and go off into central Louisiana here. And this is a little better look in terms of the thermodynamics. So our moist layer has deepened, so we've had some semblance of dynamical forcing for ascent. Um, our low-level shear is also a little more strong, about 250 meters squared per second squared of effective storm load felicity, and very long photographs that are yielding very strong deep layer shear supportive of supercells. And so definitely a favorable environment for a supercellular storm mode. Going off to the east into Mississippi at this time, um, a lot greater in the way of instability here. So into Mississippi with eastward extent, we're probably going to see a lot greater instability. And so at this time, 1600 joules per kilogram of most unstable cape and about 1300 joules per kilogram of most or of mixed layer cape. The low-level shear is also still keeping up, so about 260 meters squared per second squared of effective storm load felicity, and deep layer shear in excess of 50 knots. So again, a supercell environment here, capable of producing some pretty significant hazards, tornadoes as well. But again, we were noting how that low-level shear is going to increase going into the nighttime hours. So going to 3Z into portions of Alabama, just look at that photograph now. Look how elongated we have that photograph. So we've increased our 1 kilometer wind to 50 knots, and our winds are out of the south and have strengthened. So a much more suitable photograph for strong tornadoes, actually, because we have over 500 meters squared per second squared of effective storm load felicity, and that's in co-location with over 1,000 mixed layer cape. In addition, we have pretty strong low-level buoyancy as well, nearly 50 joules per kilogram of 3 cape, and so that's the buoyancy in the lowest 3 kilometers, which is a good indicator of how efficient the atmosphere is going to be at tilting and stretching any surface vorticity, which helps to consummate tornadogenesis. And so again, a very favorable environment going throughout time into 6C now, right ahead of that frontal boundary. Again, now we're pulling PDS tornado soundings. The mixed layer cape is actually increased amidst strong warm moist advection with that increasing nocturnal low-level jet. And so we're now up to almost 1500 joules per kilogram of mixed layer cape. And then again, with the strengthening of that low-level jet and the gradients and the open warm sector increasing overall, we're increasing that low-level shear. So an elongation and or just an overall elongation of that photograph, promoting over 400 meters squared per second squared of effective storm load felicity. And again, that 3 cape, or that low-level buoyancy increasing up to about 60 joules per kilogram. So again, a very favorable environment, and so especially across that Alabama region, looking like a favorable zone for possibly strong tornadoes. So that's where I would expect an upgrade, and going throughout time to now 3 a.m., still seeing that low-level shear maintaining itself along with the buoyancy. Buoyancy starting to taper off a little bit now, but still a suitable environment for a tornado. Uh, and by this point, probably going to be growing upscale in some more Boeing segments and a large scale QLCS. But we're going to look at what the cams are expecting. So we'll look at some reflectivity outputs in that regard. But continuing on here, I want to look at some more specific severe weather parameters. Some that we've already looked at, but just on a planar view here, so we can get kind of just a distribution of where these ingredients are going to be setting up and where the most robust ingredients are going to be setting up. So starting with our instability, our mixed layer cape, going throughout time here, most of that instability, again, relegated to that corridor from southeastern Louisiana into Mississippi and Louisiana in the early portion of the event. And then going into the overnight, we see that mixed layer cape starts to then increase over into Alabama. So those three states in that corridor from southeastern Louisiana into central Alabama, looking like a very favored corridor for the strongest storms, the most severe storms. And so eyeing that area, next we're going to look at our deep layer shear vectors. And so we annotated that our boundary orientation is pretty northeast to southwest. It was oriented something like this. And so something that we're going to have to keep in mind is the deep layer shear vector orientation because it's very parallel. The orientation of this front is not going to be very favorable for discrete convection. It's going to favor more linear convection. And linear convection is more capable of producing damaging straight line winds more than tornadoes. Discrete convection, you can manifest more supercells and therefore more of a tornado threat. So in this case, might see a linear storm mode manifest, but overall, the forcing looks to be a little weak initially to the point where we could manage to see some discrete convection. Also, we also have that morning round. Remember, we had two shortwave troughs that were going to make its way through the region. Let's go back here. So, going throughout time. Here's that first one. Here's that enhancement of the flow and the perturbation of the height contours. That initial round of convection could release or generate an outflow boundary. And so, depending on how this outflow boundary is oriented and where it sets up in the open warm sector, that could be a focus for some more discrete convection as the second wave moves in, and then we could get more open warm sector supercells to take advantage of that strongly sheared environment, which would yield a stronger tornado threat. So some small scale features we're going to have to keep an eye on. It's going to be more resolved as we get to the morning hours and we have better observations. Now let's look at the supercell composite just to look at again where all those ingredients are starting to align. So this is going to take into account your 0 to 6 kilometer shear that we looked at, our mixed layer cape, and also our effective storm felicity. And so putting all those parameters together, the most favored area initially within that first round is going to be within that southeastern Louisiana and Mississippi region. And then going into the overnight hours, expanding into that Alabama region. And so the supercell composite really blowing up across that Mississippi-Alabama border. And so definitely a focus for the strongest convective activity. In terms of tornadoes, let's look at the significant tornado parameter. This involves the same three parameters that we just talked about for the supercell composite, but it also adds the lifted condensation level height, or the cloud base height, and it also adds mixed layer sin, or the negative energy in the atmosphere. And so where that's showing up the most is across, again, that border of Mississippi and Louisiana and Alabama. So gonna have to keep an eye on this corridor and just pulling out a sounding right in that bullseye. I mean, again, extremely favorable sounding, low LCL heights, deep moist layer, 70s dew points at the surface, deep layer and low level instability, very strong, 1700 joules per kilogram of mixed layer cape and 80 joules per kilogram of 0 to 3 kilometer cape. And then that low level wind profile, extremely strong, over 400 meters squared per second squared of effective storm felicity, and more than suitable for supercells with that deep layer shear in excess of 60 knots. So an upgrade does look possible This is one model output, so we're going to jump in now to some ensemble data for some short-range models or convective allowing models. And so these are going to get us a better idea of the convective ingredients in the short term. And so starting off with our dew points, just to kind of make sure that we are actually going to get this high quality of moisture into the region. Going throughout time and into the morning hours of Wednesday, we do see a gyre of low 70s dew points creeping into the southern portion of Louisiana, Mississippi, and Alabama. And so it's reasonable to assume that very high quality moisture is going to make its way inland. Going to look at now our instability parameter here, we're going to look at surface cape. And I want you to pay attention to the two impulses that we get. We're going to get one impulse initially here. And here's that first impulse. So we get very large region of instability here, around the 1,000 joules per kilogram range, and that most unstable region. And then continuing on through the overnight hours, it gets pinched off, but we get quite a large plume of instability within that second plume, to sit right there in that southeastern Mississippi and western Alabama region, that favored corridor we were looking at. So now one more thing we're going to look at before we actually jump into convective allowing model outputs for reflectivity. We're going to look and make sure that we actually have enough forcing for ascent to get a lot of storms. And so let's diagnose that on the short range model output here. So here it is at Wednesday at 8 a.m. and right in this region I want you to focus on because this is where we have an area of divergence. And the reason for that is because we have a wind that is moving through a gradient in wind speed. So it's moving from an area of slower winds to an area of faster winds. And so I want to give you an example to illustrate how this works in the atmosphere and how this generates rising motion. So in our example in this severe weather event, we have slower winds moving into faster winds, okay? And so I want you to imagine at this point where we have slower winds that it actually represents the speed at which a car is moving at that point. So we have a car moving slow at this point, and then at this point we have a car moving faster. And so over time, as these two cars move at their different velocities, the distance between them is going to grow. And so in the atmosphere, what happens is that distance between the air parcels grows as we get a void in the atmosphere. And so the atmosphere doesn't like that void, so it brings air up from below to replace it. And that's how we generate large-scale rising motion, and we get storms to generate. So that is what's going on here in this region. We have stronger winds annotated by this orange contour right in here. And then we have yellow contour right in here annotating another degree of winds. And so moving from southwest to northeast, the wind is moving through that gradient of wind. So it's accelerating, and so we're getting a void in the atmosphere right here. And so we're getting rising motion across much of the southeast, across Louisiana, Mississippi, and Alabama. And now for our second round here into the latter part of the event. So we're seeing the same thing here. So we have stronger winds over here, weaker winds over here, and our wind is blowing through that gradient. So we have divergence or large-scale rising motion going on across the region. And so we're going to get some semblance of large-scale convective initiation and storm complexes to develop. Now for the last set of data that we're going to analyze, we're going to interpret the convective allowing model's output for the reflectivity. So what radar could potentially look like throughout the next couple hours and across the severe weather event tomorrow. So remember, we annotated that we could see an uptick in storm initiation across Texas within this initial portion of the event, and the model here for the HRRR does seem to agree with that. We see some pretty robust convective cells developing here and definitely could pose a severe threat here across the coast in southeast Texas. And they're going to continue off to the northeast and blossom expanding to a greater extent. And so, again, we could see a flash flood risk manifest across the region, very possible north of that warm front, and then to the south where those convective cells are maintaining some semblance of a severe threat. Going off to that eastern sector, those showers move off to the east, and we get this second or this new round to come through, the first round of the event. Again, going to be the less robust of the two, but something that I want you to point out, or I want to point out, is that it seems to pick out on maybe an outflow boundary right here because we seem to get some convective development in the open warm sector to the southwestern flank of that complex, as you can see right here. And so something that we were talking about earlier that could be a possibility. And then back to the west, we get more cells to develop, so it's not associated with the main synoptic front, and something that we might have to keep an eye on. Back again along the synoptic front, we're getting more convective cells to develop, and it looks like we have some isolated cells as well. So that isolated storm mode could come to fruition, and if that does, could take advantage of that strongly sheared environment to promote some strong tornadoes. But like we said, likely to grow upscale into a QLCS overnight, especially in that northern sector where we'll possibly see more damaging winds. But down to the south, where the most robust ingredients are, all hazards will be possible and definitely going to pack a punch. Now we're going to jump into part 2 of this video, and this part is going to revolve around the Day 5 outlook that's been outlined by the SPC, and this is looking to be the more robust event of the two. And this outlook is valid for Saturday, February 15th, and that's going to go through Sunday morning. As we can see, most of this region is encompassing much of the same regions as we are seeing for the event tomorrow. And so, again, looking like from eastern Texas eastward through Louisiana, Mississippi, Alabama, into the Tennessee River Valley. And so right now a level 2 out of 5 equivalent and likely going to get upgraded as we get closer because we're still 5 days out. And getting a 5-day outlook is quite rare. And considering this was actually uploaded yesterday, day 6, this is looking pretty robust. And so we're going to jump into those details. Before we do, let's name off some of the locations that could be affected. So that's going to include portions of New Orleans, Louisiana, Alexandria, Shreveport, Louisiana, Lufkin and Texas, Jackson, Greenville, Mississippi, Mobile and Birmingham, Alabama, northward into Nashville, Tennessee, and then possibly affecting western portions of Atlanta, but the overall severe risk is possibly going to expand around that. So if you're in anywhere around this polygon, make sure you are keeping an eye on those forecasts. Now with this event, we're not going to go quite as in depth, but we are going to look at a few different things to kind of give us an idea. And we're going to look at two different model outputs. We're going to look at the GFS and the Euro, both long-range models, so it's going to give us a better idea on the long-range forecast. And a thing about these models is it doesn't do a good job at resolving smaller scale features. So we're going to have to look at this, just the broad scale here and just a couple things to give us an idea of the general consensus. So let's go throughout time and go all the way to Friday. So um, let's look at what we're looking like come Friday afternoon. And so off to the west here, we see a very potent long wave trough ejecting through Baja, California, with that jet streak rounding the base. It looks to amplify over time and eject to the southeast as that jet streak rounds the base. And as it does, come Saturday afternoon, we have a very elongated, expansive jet streak on the eastern periphery of that trough and translating through the southeast. Very strong height falls with time and a pretty textbook trough for some significant severe weather. Just comparing this with the trough for tomorrow, we can see that the one for tomorrow is a lot less highly amplified. It's more broad and it doesn't really have that super sharp curvature like the other trough does. And so if we go throughout time back to this one, just comparing the two, we can see this one digs a lot more, and we have a more defined short wave embedded within the longer wave, the focus convective initiation just ahead of that. So that's the main difference between this event and last event. So usually, like we always talk about in the weather, the upper levels dictate what happens in the lower levels. So since we have a more significant upper level response, our surface response is likely going to be more robust as well. So going back to Friday afternoon, we see that that upper level wave does uh, initiate a cyclone on the lee side of the Rockies here, right here in central Colorado, and we see really strong flow and a tight pressure gradient just ahead of that. So likely a strong cyclone going to be manifesting here across the southern high plains come Saturday morning. And so going through Saturday morning now, we see that the cyclone takes a pretty eastward track through portions of northern Oklahoma and northern Arkansas before taking a northeastern turn through the Ohio Valley. But going through the Saturday afternoon period, looking at the wind field across the open warm sector, we can see winds are very strong and out of the south across much of Mississippi, Louisiana, and even into Alabama and Tennessee. Zooming in on that northern sector, again, we see that strengthening of the southerly winds and then continuing on to the overnight hours, continuing to strengthen. So, something that we're going to have to monitor is just how this wind field evolves because it's looking very, very favorable for strong low level shear. We're going to pull some soundings in a little bit, but overall, the surface pattern a lot more robust than the last one. The track of the surface low more to the north, and likely going to pull more of that moisture inland, and a deeper surface low to promote stronger winds in the open warm sector to again enhance that northward flux of moisture and also promote stronger low-level shear. So overall, the synoptic setup is looking more favorable for the next setup, but something that's really going to be a dictator is just how high quality our moisture is going to be. And going into that Friday and Saturday time period, we start to see that northward flux of moisture and a high quality bunch of that. So low to mid 60s and even upper 60s pinching into the southwestern portion of that warm sector come the Saturday afternoon period. Not quite seeing 70s making its way into the northern portion of that warm sector, but uh, we're getting that 60s dew points plume all the way up to southern Kentucky. And so large warm sector, we can see the real estate for storms to work with is going to be very large, a very large west to east component to that warm sector. Let's just outline what our warm sector is going to look like in the afternoon time period of Saturday. So going back to about 21Z here, again, our surface low positioned across northeastern Arkansas, cold front stretched down to the southwest. And it does look like it's more of a cold front. The moisture gradient is pretty diffuse, and so I would characterize this as more of a cold front coming through this region. And so uh, again, the reason why I drew out this cold front though is because if we compare this to our deep layer shear vectors, gives us an idea of storm mode. So right now it's looking very parallel, and so that's something that would be more suitable of initiating linear convection, which is would yield more of a damaging wind threat more than anything. However, this is going to be an evolving factor, but it's something to take note as we see how the models trend going into the future. Another note of the deep layer shear vectors is that they are, in terms of magnitude, strong enough to elicit strong convection. So the deep layer shear magnitude is going to be more than suitable for organizing convection overall. Now I want to pull a sounding. Let's just pull one out of central Mississippi here, Saturday 21Z, just to get an idea. And right off the bat here, a pretty textbook look here in terms of southeast tornadoes because we have a pretty buoyant atmosphere with a moisture-laden boundary layer and low LCL heights, and that's co-located with strong low-level shear. Classic southeast hodograph there, promoting upwards of 400 meters squared per second squared of effective storm model felicity. And so definitely suitable of a tornado environment to some capacity. And then going into the nighttime hours, let's look up in the northern sector here. And across southern Tennessee, we have very strong low level shear, but the instability is looking to lack. So northern extent, gonna have to see how that uh, buoyancy profile evolves, but long-term models are notorious for doing a very bad job at reflecting what the buoyancy profile is going to look like. And so the shorter range and medium range models are going to probably do a better job at actually resolving that. Now, this is where we transition to a different model output, and this time we're going to look at the Euro model. And again, we're going to go through the same process as we did before. And so at 500 millibars, and trying to really see the difference between these troughs, um, in this model, we actually see a more neutrally tilted trough. And so what I mean by that is that when we draw our axis of our trough, the tilt of that axis is what we mean by negatively tilted or a positively tilted trough. And so this one being more north to south oriented typically means a stronger trough and more meridional flow in the exit region, which would elicit more uh, vorticity advection and forcing for ascent. And we can see even a stronger jet streak as well rounding the base. So looking like a stronger trough on the Euro model. Uh, the surface reflection will likely also be a little more robust going throughout time into the Saturday time period. So, looks like they both develop across that central Colorado region and right around that 1,000 millibar pressure level. However, the track looks to be a little different. The surface might take a double, more of a double barrel approach where we have this more southern mesolow, and then we have the synoptically driven low to the north. If we look close, we have a cyclonic circulation up here into central Missouri, but we have also a low pressure system down in here. So could be a double barrel low pressure system situation where we have a frontal low that develops in this model run. They seem to become one with time, so that's typically the result of that. But it has a pretty deep cyclone in this model run, which would also elicit a very strong wind field in the open warm sector, and we can see that reflection here. Zooming into the sector here, that wind field again is relatively strong come Saturday 18Z and maintains itself as that surface low approaches, of course, through the remainder of the afternoon into the evening and overnight hours, uh, affecting much of the same regions though, so we can kind of make that a note that the same regions will be affected. Now, something I want to do again is compare our deep layer shear vectors to our initiating boundary, just to get an idea if maybe this model run has the uh, frontal boundary oriented a little different. And in this run, it actually looks like it does have it oriented a little different. And I was right on the money by saying that the orientation of this front is more north to south. And the reason for that is for that more meridional flow in the upper levels. And so this is yielding more perpendicular flow to that front. And so this would elicit more discrete convection and more of that tornado threat. Now to look and see how the surface dew points evolve going into Saturday morning. Again, we see much of the same areas getting widespread 60s dew points. The northward advance looking to, again, go all the way through Tennessee and also into Kentucky off screen, but much of the same quality of moisture around the low to mid 60s looking to be a reasonable amount to assume. And so let's go to the afternoon hours of Saturday across central Louisiana and Polo Sounding and see how this looks in comparison to the GFS. By the looks of this profile, we can see that the buoyancy profile is probably a little stronger than the GFS. We can see a lot stronger dry air intrusions, which would elicit a steeper lapse rate. And so we see that most unstable cape in excess of 1,500 joules per kilogram. That low level shear profile, again, not terribly robust for tornadoes, but the deep layer shear profile is definitely going to be suitable for some supercellular storm mode and some organization of that convection. Going off into central Mississippi now, again at the same time, the buoyancy profile is not quite as robust at this point. The low-level shear profile is a little more enhanced, promoting a little over 250 meters squared per second squared of effective storm level felicity. Let's go into the middle portion of the afternoon hours, and by this point we have increased our instability, almost 1400 joules per kilogram of most unstable cape. Low-level shear profile has decreased as we would expect going into the mid-afternoon. The low-level jet does go through that cycle of decreasing into the afternoon, but going into the evening hours would tend to increase again, and we see that reflection on the hodograph over here, much more elongated hodograph, over 50 knots of that 1 kilometer layer. So strong low-level shear in excess of 400 meters squared per second squared of storm level felicity. Buoyancy profile decreasing with time, but again, these models don't tend to do too well in the long range at resolving the buoyancy profile. Something to keep an eye on is just how strongly shear this environment is going to be, and if we can get any semblance of instability to build throughout this environment, we have a very suitable environment for strong storms. So that's going to do it for this video. Hope you guys enjoyed. Again, we have a slight risk, level 2 out of 5 for severe weather across the Gulf Coast states tomorrow, February the 12th. And this is going to include tornadoes and wind. A 5% tornado threat alongside a 15% wind threat likely could be upgraded in the near future. And then going into our day 5 and Saturday, we have another slight risk. Definitely going to be upgraded considering how far out we are, and a much larger region expected to be affected. So keep an eye out if you are in any of these regions in the highlighted polygon. But that's going to do it for this video. So if you have any questions or want any more information on this event, let me know. And I'll likely have another video out on the Saturday event as we get closer and we get better model guidance. So hope you guys enjoyed and have a great rest of your day.